researcher. He has already published more than 60 number of journals in international journals, and he has guided more than three guided, and already 5 people are undergoing PhD already. He has already guided more than 20 numbers of MTech students. He is having more than 3 number of patents in his name. He is a pioneering person in water resources engineering. So now welcome to sir our program. So now I will request sir to deliver his talk. Our student is definitely immensely enriched by his experience. Thank you. Okay, sir. Thank you.
Okay. It is also a nice privilege from me because I am happy to do this program, particularly to give a guest lecture on behalf of NIPC chair to the faculty member. I want to introduce myself. First of all, as Professor Satpathy has already told me that I am having some patents. To be very honest, as patents is concerned, let me highlight you. There are several papers which are giving me money unnecessary going to several patent publishers like you can say England or whether some other countries. But in the Indian, at the level of base of Indian continent, if the Indian patents are right, then definitely originality will be much more accepted as on today's market. So from that point, as Professor Satpathy has already told, I acquired 3 patents by my own, and I have worked minimum for 15 years for that, and 3 particularly at my personal level. Though I am working more specifically from my biodata, I am more interested in water resources engineering. My prospects in the areas of, it means I am more conversant with artificial intelligence, and my basic works are with generally remote sensing, GIS, MCDA, as well as artificial intelligence, and more specifically, if we look to artificial intelligence, rather I should tell that I am more conversant with machine learning. So in any way, to start this program, effect So to start my lecture, what are the contents of today's topic? First is, I have to give an enormous introduction to water resources management and broadly remote sensing and GIS fundamentals, water resource monitoring, water resource monitoring with remote sensing applications in hydrology, GIS in water resources management, introduction to integrated GIS as well as MCDA, and MCDA methods and the techniques. And next is integration of spatial data in MCDA. And this lecture one also constitutes some other more contents like spatial decision support systems, natural resource management, emergency management and disaster response, case studies and applications, challenges and future trends, training skill development, softwares and tools, and more specifically, what are the policy making at the level of government, rather policy making and governance. So to start with this, what is water resources management? Because I expect 90% persons should be water resources only. Am I right? So in any way, so some holistic approaches I want to tell you what is the logic, what is the ethics at our level, particularly being a researcher or being a faculty member rather. First, we should understand what should be our associative tasks, with what tasks we are being associated, particularly in the field of water resources engineering. So what should be our ambition or what should be our goal? The goal is definitely, first we should understand, we should guarantee, we should give a 100% confidence regarding the policy making. It means regarding the quantification of water resources. And we should have side by side, we should have an interaction for the quality approach to meet the demands of water resources. So then, as you know, broadly, these needs, these requires what should be the planning, what should be the determination of problems, and what should be the representative solutions. So to understand that one, we should let us have a slide like this. We should promote this type of things, particularly it should be coordinated with development. And as I am telling you, management of water resources, you know, water resources, where from these water resources will regenerate, where from you will get it. It is very prospective that we should be dependent upon the three things, particularly we should identify what should be the uh, what should be the uh, um, approaches, particularly to understand the strategy. You see, as I am telling you, the strategy, we should implement what should be the methodology or what should be the strategy, particularly. To understand the strategy, first of all, we should depend upon the methodology which we should expect for the approach for the problem. Okay, so what should be the problem, what should be the approach, what should be the methodology, and we should implement what should be the strategy for that. Second one is, as I am telling, once you develop the methods, once you understand or think the methods we have to apply. So what we have to do is, when you are applying the methods, you should have a concentration towards how to monitor and how to evaluate that assessment and how to adapt. Because you know, monitoring, evaluation, and adoption, all these three parameters are important at the level of applying the project or to start the project work. So for that purpose, first of all, we have to identify what is our problem. First you identify the problem, then you go for the beneath. Beneath means what is the support. Suppose a problem is, I am interested to solve a problem. There is a spacious area and where say population is too many. How much quantification of water is required before thinking about the quantity? What should be the resources? Where from the water will come? So for that purpose, we have to first think about the periphery. That is, rather we have to think about beyond the beneath. Are you clear? Don't you? So then we have to look after what should be the appropriate approach, and then we should think about the methodology as I am telling. So as a whole, you know, IWRM is a process that promotes coordinated development and management of water issues, land issues, related resources, and we have to think about, whenever we are thinking all these resources, we have to think about the economic, the social welfare. Suppose we think that whether the fund is sufficient enough to go for the project or not. Side by side, we should also think that whether some peoples are being affected or not, and the economy, whether it is permitting for us or not. So looking to all these things, we have to concentrate upon the integrated water resources management. Why integrated? As I am telling you, suppose this is a locality. In that locality, you might be saying that there are roads are there, buildings are there are several cultural activities are there, some programs are there. So in that connection, if we are not, you see, you just let us take an example of the Bhubaneswar city itself. I am from Bhubaneswar, I know how Bhubaneswar is running. You see, you might be saying in from door to door in every day, somebody is coming, some authority is coming and they are going digging for the roads. But without thinking the proper plan is being approved by IIT Kharagpur, I know. BDA is getting that plan set up. But the question is, once the planner they have given, planner and the authority, those who are giving the projects, they are not being associated. So that's why the integration lacking. So my main idea is, if you are getting a project, integration is most important from the authority side, those who are giving the works, from the planner side, those who have developed the plan, and execute. The execution is again side by side most important. So that's why the integration of water resources management is necessary. And to integrate this one, these are the three components, there are several things will come into picture. What are those things? First one is, as I am telling, how much water supply. Then if water supply is readily there in a, let us take any city say, then what should be the worst water treatment? Water is supplying, what should be the treatment for water, and how much water is being expelled out from residential buildings or something like that, or from even industries. Then for that purpose, we should have to concentrate upon the treatment. Okay. So if treatment is not there, then definitely its pros and all other things will come into picture. As a result, there will be definitely be a loser to the treatment, loser side to the treatment. So for that purpose, some other projects like say storm water management. Okay, say storm water management. How to manage the storm water, that is also an important prospect. So you see, suddenly rainfall occurs. Say let us take an example of Bhubaneswar city. If the city is not properly planned, what will happen exactly? Properly planned, I means I am taking the consideration of the watershed prospects. What are those watershed prospects actually? As you know, watershed prospects should be whether the road is being in a proper slope or not, whether the other say societies which are being developed, whether at the proper location or not. If it is in proper location, then where should be its situation for optimizing the water resources. Then comes the water conservation. As I am telling you, if you look after water conservation, this is an important term. How to conserve water. If we citizens or even if the bureaucrats, they do not understand, then there will be a issue day before in Palasuni, because the day before yesterday I reached only at Bhubaneswar, I have marked these, that 2 days water supply is not there. So people are facing problem. So it may be an accident. Of course it was an accident, but why the accident will occur? If a proper management, proper planning for conservation of water is there at the site itself, then I do not think that, or any researcher or any authorities, they should not face the same problem. It is the day-to-day life, not only at Bhubaneswar, not only at Delhi or in some other places even. So that's why water conservation is an important parameter, particularly for you researchers or water resources engineers. So it is a broad prospects, we have to think about that. Then, as I have already told you, the watershed management. You come to the watershed management, you look after. Watershed management means, you see, what is watershed management exactly? To manage water in any catchment. You see, you think about, say, nearest to Bhubaneswar, I am taking the nearest examples. That is river Kuakai. Okay. Upon river Kuakai, Kuakai is definitely, a river which is being assembled by two multiple cities, rather that is called what? That is called Cuttack and Bhubaneswar. In between these you are getting. So in Cuttack there are several contractors. What they are doing? Are they thinking about the beauty or the management of any catchment or any watershed? Not at all. They are getting land, they are going developing several houses, residential buildings, etc. etc. So because of that, what happens in rainy season? Even if you might be showing several waters are being arrested, even in cities. So because that is, as I want to say you, that is called a part of watershed management. How to manage water, how to divert water from one sense, from one catchment, and how to divert it particularly from canals, from enrichment of any localities or colonies, how to divert water from one reach to another reach. That is important. So that's why watershed management is an important parameter for which we have to look after several components which and rather I don't want to discuss. You think about in a watershed, whenever you think the flood plain management, which is an important prospect particularly in monsoon periods. during rainy seasons, what happens? As I was just discussing, there are several areas which are being surcharged by water. Running, driving, communicating, there are several problems will come into picture. So to withdraw all these, whatever I am discussing at present in these slides as a integrated water resource management, I am discussing about the problems. Then what should be the probable solutions, that I will discuss. Okay, in any way, these are the problems we can expect. Okay, so how to and this is a water cycle. This is everybody knows, so I don't want to discuss how the water comes from, what are the sources, how the water is being evaporated and then generated in the form of cycle. All these phenomena known to you, so which I don't want to discuss. Our main purpose is then what are the, in this integrated water resources management, the principle is, if you look after these prospective parameters which are most important to understand IWRM, integrated water resource management, what should be the allocating point, how the water once allocated, how it is to be monitored, and particularly during monsoon period, if we think about the flood, how the flood can be managed. If you think about the drought, particularly in Kalahandi regions or wherever the water is not expected or water sources are rather diminishing, nowadays even if how the groundwater depletion occurs at several places. So that is, there is a question of drought, and particularly in western sides of Odisha, if you think about a local region rather. So these are the perspective, and then the question is, the scientists or the stakeholders rather, at any side, if they think about stakeholders, means you are a stakeholder, I am a stakeholder, everybody is a stakeholder at every locality. If you do not think about the availability of water, we unnecessarily go for definitely in the negative side. I mean, distracting water, what will happen? One day, ample amount of, 3/4 water, 3/4, you see, 3/4 water is readily available in the earth's surface. But can we researchers, or even if the stakeholders, those who are authorities or something like that, can we properly manage water? Not at all. Because you see in Odisha, sea beach, Puri sea beach, what will happen? There is a ample water is there, but at Puri sea beach, you might be saying the people are going for procuring water. So why? The simple situation is because we are not being managed. There are several waters are readily available, but the water, so what, in what format? Salt. In a so saline water rather you can say. So we can get two types of formats of water. One is a riverine water, another one is a saline water. So riverine water, it means whatever the water we are getting expected from fresh water is from rivers. So we can manage those riverine water. But the question is how to manage the saline water. If you understand, or if the bureaucrats, technocrats, if they understand, then probably the solutions may be enriched in a better format. So looking all these conditions, we have to concentrate. Now there is a question. Whatever the slides right now I have discussed, 4, 5, 6, 10, whatever the slides I have discussed, we are much more worried about the water resources and being a manager, how to manage the issues. So if we are able to manage the issues, by what method we can manage? Now we have to think about it. So what are those methods? There are several methods readily available. First, the methods are broadly, if you being a water resources manager or being a water resource researcher or engineer, if you ask me a question, then I can say you by to manage water, the first point is the peoples particularly, we should be aware. First point is we should be aware about water. If once we should aware about how to aware about water, because we do not know. I am entering into your NIT, sorry, not NIT. I am entering into your CET campus. Are you clear? Whenever I am entering into CET campus, I was probably thinking about there are several resources, forest resources. There are several roads. It was just it was not at all developed. Now it is plentifully developed. But when the development is going on side by side in an area or in any catchment, we have to think about, because you see this area is a small area. You can just observe, as being an observer I was observing. Suppose this area is very big. So what we have to do? Very big means in the sense of I am thinking about pura entire Odisha. So as a researcher, as an engineer, or as a planner, what I should do? I should think about broadening methods by virtue of which, by sitting here, by standing here, I can manage, I can think about probably these waters, because I may not be accurate, but I can approximate it. Approximation is much more important. So to approximate the resources, we have to think about different methods, and that is, the method should be scientific one. So how the scientific methods, if we want to run it, if we want to think about it, then we have to concentrate upon some methodologies. So what are the methodologies? First methodology is, it is coming into picture. Everybody should have an idea that what is remote sensing and what is GIS. What is remote sensing? As you know, remote sensing, the word itself is telling you, sense the remote areas. To sense the remote areas, if you understand, sense means you have to understand the remote areas, and understanding remote areas cannot be possible by moving from this place to that place. So what we have to do, being a scientist, we have to think about some technologies, or we have to take the help of some devices, rather we can say. If you take the help of some devices in terms of accruing knowledge, first you have to acquire knowledge. Once you acquire knowledge, then after that you will definitely be ready to apply it. So whenever you are ready acquiring the knowledge in terms of remote sensing and GIS, then only you will get an interest to apply it in the field. Once you get the knowledge and you are trying to apply in the same field, then you can think that probably I am doing something for the society or for the area or something like that. So to understand that one, I am telling you the first proximate area for a water resource engineer is the basic method. You should know what is remote sensing and GIS. For what purpose? For locating how much water resources is available in terms of surface water, in terms of groundwater, and what are the resistances or resisting structures are coming into picture. So for that purpose, for that purpose, okay, before that, before entering into remote sensing, let me think about a story rather. What is the brief story for remote sensing through a video? At least you observe 2 to 3 minutes, then only I will again proceed and I will share my knowledge, whatever the knowledge is with me. Play color. So please concentrate and have a basic knowledge regarding this one video. So you see, through this video, I want to give a message that before starting remote sensing and GIS, we should at least have a broader knowledge that we should have to think the entire enormous world. What is the possibility? You see, whenever in a survey, because you all are civil engineers, you should know, if you are starting survey, you are starting the work from whole to part. You are starting from the boundary to the center. Am I right? So in that connection, if you look after for GIS and remote sensing, then globally you have to think. The entire world, the entire world picture should come into your mind. So to sense the remote sensing means to understand remote sensing, rather I can say you the process, what are the process are being associated. First process is, if we are interested to analyze any problem, so what we have to do? The important parameter is we definitely have to think about that in what areas we are thinking about and in which area we are going to work. If that area is associated with which kind of the preliminary element is which kind of data is being associated to put in for application purposes. That a researcher have to definitely think about it. So in that sense, I can say you that the process of acquisition of data is an important parameter, and that should be the first objective. So what should be the first objective? First objective is, if you want to think about GIS, then you should understand what is the readily available data in that locality. So first you have to sense the data, and the second one is, what is your objective? Objective is, you are considering which problem. If once your problem is clear, your data are there, then what we have to do? You have to start the direct assessment for application of remote sensing. Okay, is I am telling you what is remote sensing. That to understand some basics you know, but I am just telling you that at least the basics I am telling in that sense, such that you can understand the methods. Okay, how the methods will be utilized, that will be my main perspective. So for that purpose, you should understand the physical areas first. What are the data readily available in an area, and what are the physical parameters associated with it. Once it is enlisted, then you have to think about application. So before application, some basic things I want to tell you. बंद कर दीजिए, नहीं मूव कर देखिए, सिद्धबाबू रूम रे अछि यस से लैपटॉप बैग टा भितर अछि. Okay, in anyway, it is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance. So distance is again a parameter, most important parameter, which you have to understand, because you see, suppose this is the river Mahanadi. Okay, so at the river Mahanadi you are getting Bhubaneswar, you are getting Cuttack, and you are getting several locations which are coming across. But question is, we are water resources engineers. Question is, at what distance or at what slope the water is migrated from one place to another place. That you are an engineer, you are a researcher, you have to think about it. So probably the distance is a parameter you are getting. Okay. In a similar manner, as I am telling you, is a water set. What is the meaning of actually a water set? So I am entering into an area that is this campus of OUTR. Okay. So if I am entering into the campus of OUTR, first I should understand what are the data or what are the things are available inside the campus. Might be 6 hostels, might be 2 roads, might be some academic buildings or something like that. But where it is located, at how much distance from the how much distance from the administrative building, because the administrative building is an focus point for any organization. So if you understand, because this is a small area, you can measure simply by taking your, now my, what is GIS, I mean without measuring with different formats, without measuring, you can put me a question, sir, how can we measure? There are several scales readily available. So that scales are in terms of certain that scales are you have to put, the researchers have to put. So to put that scale, to accelerate or to understand what are the physical features are readily available at a site, starting from 50 kilometers square to 1000 and 1000, even lakhs and lakhs kilometers square, you by sitting at a single place, you have to look at, you have to cite. What are the main features? Suppose you see I am a consultant, I am working for some defense projects, I am working for some railway projects, RVNL, several bridges, I am being associated being a water researchman. Okay, you can put me a question, you are a water researchman, how you are doing all these things? Because the party demands that if somebody is putting knowledge, it does not matter, you are a water research engineer, you are a structural engineer, I am a man of birds from all feathers, are you clear, don't say? So I can teach even if structural engineering anything. That is an interest. That is a question of interest. So why I am telling, the interest will come if you understand the sense of, suppose a road you are interested to develop. For that purpose, I do not know. Somebody assigned me that you develop a road at USA. I am sitting at Bhubaneswar. How can I go for that? So definitely for that purpose, I have to take the help of the scenario which is readily available at globalization, at global level. So for that purpose, I have to go for what? I have to take the help of remote sensing and GIS. It means I have to think about the geo information system which is readily available at space approaches. Just 1 minute, probably not getting. What are those processes? Because there are several slides I have to come across within a very short period. Okay. So what the remote sensing processes is being associated, as I am telling you, the remote sensing processes are, first one is radiation by energy source. As you understand, energy source at the space is readily, you see, anything is projected. The great, is it possible to operate at the night beneath? Yes or no? You tell me please. Yes. If yes, then how? Or in what way we should be? Yes, definitely your answer is very much correct. Yes, because if it was not possible, then night operation cannot be possible. And you probably we might not sleep, because I am at the border. I am at Silchar, I am at the border. I understand what is the sensation of Chinese people. Are you clear on say? So how they are in a mood to rather attack at any time. Okay. So from that consent, so we are too great, we are too much energetic. By mercy of God, we are taking the sunrise. As a result, the radiation energy helps us to sense their activities. And that is only possible because of GIS, the blessings. Are you clear, don't say? So technology, how important you understand. Okay. 12 years before, when I have joined to NIT Silchar, I have seen what was the status there, and at present what is the status. And most probably you think about Modi government, rather I can say. I am not giving any political talk, but I want to say you how the people are being associated with scientific work at present. How the peoples are readily getting the help of remote sensing and GIS. So one point is the first point is the radiation by energy source. Second point is the in that point we can understand the illumination of radiation, because if you understand what the technology is there, if the illumination efficiency, you understand what is an illumination efficiency. If the illumination efficiency is up to that level, then your pictures, the pixel scales will definitely be much more. As a result, the figures will be very much clear. Otherwise, they are sitting at some places, Chinese people at the center. What is their works are being done, Indian people understands or Indian soldiers understand. So that is the first one is because of the illumination capacity or radiating capacity of the sensor. So sensor plays a vital role. It may be remote sensing means through sensor we are getting the pixels out of which we are getting the photos or pictures. So that is our important point, and that is at the level of, that is only possible because of the technologies I am telling. Then second point is interaction of energy with the atmosphere. You see, a sunny day, foggy day, you might be listening, flight cannot move from one place to another place if it is too foggy. So atmospheric criteria is coming into picture. So to sense the illumination, to sense the efficiency or illuminating power, the atmospheric conditions should also be permissible, or it should be up to that level. So then the target is with what capacity or with which energy, the way to target through the atmosphere is in possibly depending upon the properties of both target and the radiation capacity. Both target and radiation capacity, or rather the radiation. So that's why we have to understand the reflected or emitted energies from the target. Okay. Then the sensors, as I was just discussing, then comes the transmission, the reception and the processing, then how it should be interpreted. Then comes, once you demarcate the features of any sites, then how interpret. Interpretation depends upon the capabilities of the persons. Analysis depends upon the capabilities of the persons. You cannot point me that you are not a good analyzer, how can I work with you? A very simple answer is, analysis is only possible when efficiency of person works. And analysis again, you know, there is a criteria for percentage error. If percentage error or efficiency is coming into a broader sense, then only your approach for sensing the process will be more accurate. So that you have to look after. Then comes the application. What are those applications? As I am telling, what are the applications and at what platforms these applications will hold good. So to understand the remote sensing platforms, you should have to have a knowledge at what platforms the remote sensing pictures or pixels can be taken up. To start with that one, the first one is, you know, there should be a base. So base from what you see, the airplane is at the sky, as I am telling you. The base is, as I am telling you, the stationary or moving on which remote sensors are mounted. And this remote sensor, where it is mounted, that is a platform. And that platform is generally either it may be stationary or it may be a moving platform. If it is stationary, then observation will be up to certain level. You can get some photos, you can get something, but it is moving like aeroplanes or rockets. You see, there are three platforms I am telling. From ground base, from atmosphere, and from space-based platform. Three platforms you can get. From ground you can take photos. From atmospheric means with the help of aeroplanes. From space-based means with the help of satellites or with the help of rockets. Are you clear? So looking to the situations and edge, because I have already pointed out the distance is most important at different levels. So then comes what are the geographic information system and how the real world is existing and at what different layers how the data will be collected. These things you know, but I am just revising rather, because if I do not tell you the basics, we cannot enter into straight with the methodologies. Okay, so that's why you, as you know, what is GIS? A computer system for gathering, storing, verifying, presenting data about locations on the Earth's surface is called GIS, or that is called Geographic Information System. And to understand how GIS helps to extract the data, there is a scale leveling, several layers you will get, and that layers is called GIS layers. To understand those layers, you have to approximate how the at different layers we will get. So for that, certain scales are there. So what are those scales? And how does the GIS work? GIS can work in by associating the data, by associating the maps. Once you get the data, once you get the associate maps, then there will be a question of analysis. What are the data? What are the maps readily available? And with these data, how the maps will be associated. So that is I am telling you as analysis. After analysis, there will be a development of apps. We are developing some patents, or we are developing certain something like the softwares. Similarly, the researchers can develop certain apps at the GIS platform. And once you get the apps, because you people are well conversed with any sorts of apps, once you get the apps, from that readily you put your data, you put your pictures, you put your maps, you can extract where my residence is, where the CET building is, where IIT building is, or like that. So for that purpose, you know, or you have to understand the phenomenon, either you know or you have to understand. So for that purpose, one important parameter or one important factor which is regenerated particularly in this platform, that is called spatial data. Because data you can get in several platforms, but spatial data is different. How it is different from other data? Because spatial means more accurate and more accurate in the sense of with respect to the location, with respect to the position, with respect to location and position, whether you can say. So for that purpose, what you have to do is, you have to give the coordinate system, you have to develop the directions, you have to put the features, and you have to give the magnitude. Extract that one. Generally, some scales or some methods are there, or the data methods. One is called a raster data method, another one is a vector data method. What is raster, what is vector? Because you know vector means it will be associated with certain directions. Okay, so once you get the positions or locations of certain data, then you can go for the vector data, and the raster data also you can extract it. Okay, so the vector data and raster data, these basic things I want to I don't want to discuss these things, you know. So rather I should concentrate upon some other things. What are the disadvantages of vector data? What are the disadvantages? Because you know the location of each vertex needs to be stored explicitly. What is explicitly? And what is implicitly? External and internal, in that sense, rather you sense. Then what should be the vector data which should be converted into topographical features or topographical structures rather. And rather you can, to understand that one, you have to update or edit the vector data wherever it is required for rebuilding the topology. Because you want to associate, because you have seen, suppose this is an area, you know here 50 or 90 tables are there, but you want to give some more tables. So for that purpose, you have to think a space which you have to generate in that vector field such that instead of 60, 120 tables can be accommodated. Okay, So that is your idea, or that probably the scientists or engineers have to think in any field. Then in a similar manner, what are raster data? Raster data is again you have to look after, depend upon certain cells, and this is cell based data such as aerial imagery and digital elevation models which you have to develop. And generally, raster data is not, this is faster data, this is raster data. Raster data should be characterized by the corresponding pixel values, that the basics. And generally, sometimes this pixel is assigned with a specific value. It starts from 0 to 255, which you know or you try to know. Then what are the advantages? Because advantages is, what are the best advantages, that is I want to tell you. Analysis is faster. With raster data, analysis is faster as compared to vector data. Analysis any analyst can do with great speed, rather I can say you. And the computation is also possible faster as compared to vector. So all these things you know. Then I want to skip some. Then what are the functions? As I was discussing, for maybe a vector analysis, for be a raster analysis, the functions you have to look after. Functions are density. Density means, let us take the example of this city. How dense this city is. Density depends upon what? Density depends upon, if it is a road, what is the road density? If it is a building, what is the building density? Means number of buildings associated with the town. In a similar sense, you try to understand how much distance it is allocated, particularly from a central place. Similarly, suppose you see some data are readily available. Here is a residence, here is a residence, here there is no residence, or some space are being available. Some space are being available. So to properly design or to properly planning, what should be the missing data readily available? So you have to take the help of the missing data by interpolation. Several points are known, several buildings are known. If you interpolate, that interpolation can be possible in raster format. Okay, and the what should be the for analysis purpose, these parameters you can consider as a whole. I am telling you. One is what should be the characteristics. Particularly characteristics, I mean characteristics in different sense. Suppose we are going for analysis of runoff characteristics. In monsoon period, several rainfall occurs. Okay, I do not know where it is a very biggest area, but to analyze that at what area, at which area the drainage system will be blocked or the water will accumulate at a single point, that you have to probably analyze by characteristic features. So what are those characteristic features? Suppose rainfall occurs at Palasuni and I am here at CET campus. I do not know water is, say you for a time being you think that there is a greater slope at Palasuni and this is a lower one. So water will automatically come divert from that greater height to the lower height, because that is the property of water, you know. So for that purpose, how much distance it will come at what time, space and time, both you have to accumulate through analysis. So whatever the parameters I am telling, which problem you are considering, for that problem what should be the associated parameters and what analysis is required, then we will think about probably what methods we will apply such that we can either quantify or we can extract distract the problem which is not going to be happened, or we can give certain that is called what, we can give to the authorities, these are the probable areas for which purpose we have to concentrate, and the characteristics should not be like this, the features should not be like this. Features means the slope should not be like this, the distance should not be like this, the aspect should not be like this, and the interpolation should be done like this. So these all parameters you have to little bit concentrate. यार बैटरी सरी गला ना कौन ଟିକେ ଦେଖିଲା এটা କାଇଁ মুভ করলো. Okay, anyway, then what are the applications of GIS in spatial data analysis? There are several applications as being enlisted. You can look at the screen. One is urban planning, second one is environmental analysis, third one is the public health, the natural resource management, the emergency management and disaster response, the transportation and logistics, the real estate property management, the archaeology and the cultural heritage, the business intelligence and marketing, even if so many features. So to understand that one, you can put me a question, sir, why you are telling so many things, why you are interested for remote sensing and GIS, in what way it will help? Very simply, I am telling you, sitting in your office, sitting at your location, you have to analyze in such a manner that will help probably, because time and space, two characteristics are more important factors. By sitting here, if I analyze, if I give certain suggestion to the authorities, then probably the application may be helpful for setbacking the monsoon periods, or not to create the havoc during monsoon periods, because several people, several cars, vehicles, etc. are being stocked. So if a proper planning and a proper assessment through GIS is possible, the assessment may be submitted to the state government authority, then probably the solution may be made, and that may be applied by engineers, which they will execute, and the works may be controlled. In that sense, I am telling you. So what are the different types of GIS tool? You know all these things. I don't want to, or even if you do not know, you start working GIS, you try to understand what is the readily available. This is just an information. I don't want to discuss. At different scales, you will get several scales, several tools are there. Like hydrology is a tool, like your borehole is a tool, climate is a tool, landform is a tool. Several in GIS platforms you will all get all these tools, and as per your problem set, you can design yourself. You can develop the papers, what is the problem, how to analyze, how to give the solution. At every scale, that is much more required. Then GIS data acquisition. As the name indicates, what is the meaning of acquisition? Collection. Acquisition matlab collection. How to collect the data? To collect the data, there are several processes. As I am telling you, first one is you can go. Very simple is a layman. Layman, I mean a labor class people. He can go to the field, and at least he can put a scale and by survey. That is rather I can say field surveys. Okay, gathering data direct. When you come to GPS, you are a scientist, or you are a acknowledged person. You are having certain knowledge. You understand what is geo-positioning system, and total stations and other surveying equipments. So through those surveying equipments, you have to compute the field survey, you have to acquire data. That is, I am telling, data acquisition or data collection rather. Then some that can also be possible by we technocrats with several knowledges, like at the platform remote sensing, by using satellites, by using aerial photography, through LiDAR, or through drone. Nowadays, because I am doing my project work with the help of drone, people are now associated. Arey bhai, मैं PhD scholar हूँ. Should I go to the field? Should I measure? It is going beyond my imagination. Yeah, faculty member has told. How does it matter to me? Sir, if you give drone, then only I can. Arey, you do it. If I am telling, nobody is ready to listen. I told always, usually you see, I am having probably my 4th PhD scholar is running. I have joined too late, but I have at any moment I have not wasted time. That is my practice, and I hope it is also through my talk I am giving you a knowledge. Once you have an interest to do something, उखाड़ के फेंक दोगे भाई. I am sure about it. Okay. So in that connection, I want to give you a message. Some probable data which generally the PhD scholars avoid. In through that sense, I am telling you, the PhD scholar should not avoid. It may be a field work, it may be a technical work, it may be the work through GIS, it may be the work through any tools or something like that. So in that connection, I want to give how data is important, how data collection is important, how data gathering is important, and how data bringing into a platform for analysis is important. So that is the sense I want to tell you. So for that purpose, these tools you can utilize. If it is a sense of bigger areas, then you take the help of remote sensing and GIS, take the help of LiDAR, take the help of satellites, all that. You see, I am sitting at northeast. There is, the physical features are not permitting, or Permitting into some extent may not be permitting 100%. That is a given message. So for that purpose, what you have to do? You have to take the help of satellites. Are you clear? You have to take the help of not aerial photography. You have to take the help of space photography. That is called what? Take the help of leader, take the help of rockets, take the help of a greater altitude equipments, whatever readily available. So for that, that is the other way for data collection. Then the second one is secondary data sources. What are those secondary data sources? I was telling a layman, if you ask me, a labor comes and you ask me, "Bhai, you just tell me how much distance from Palasmani to this place." A labor can say that, "Bhai, it is approximately 20 kilometers." Okay, but I am not thinking about 20 kilometers. I am thinking about kilometers and kilometers in terms of lakhs, in terms of any other thing. So for that purpose, what we have to do? Generally, you have to collect the data what are readily available in the global platform. Say you are telling there are several agencies, you know. What are those agencies? Suppose I want water resource data. Where from I will go for? I have to Indian agencies. I have to look after like IMD, Indian Meteorological Department. If I am interested for climatic data, I have to go for Indian Meteorological Department. If I am interested to know about river data, I have to be dependent upon CWC, Central Water Commission, and so on and so on. So several agencies data in a similar manner at a global platform. You readily available data is, you know, you are telling that America is #1 country. Why you are telling? The simple answer is they have developed up to that level through technology. So US GIS data is readily available from you are taking the help. Similarly, our platform data is at the level of GIS data. Where from you will get? From ISRO. Several sources are readily available from that. You have to, so data collection is, it means I want to give a message that data collection by knowing the proper platform is important. Where from this data will be available? That is the first idea for a researcher to understand the whatever the data point or whatever the data I am escalating, I want to escalate, where from I will get. Then you go for escalation, that is called collection of data in several platforms. Then water resource monitoring with remote sensing. Next topic rather I can say, into some extent I am highlighting. And this is I should skip also because monitoring I have already told several things. Then what are the challenges? Challenges in water resources monitoring. When we are going for monitoring means, monitoring word is very, monitoring means if heavy waters have to, monitoring means if a readily available plenty amount of water is if plenty amount of water is readily available, then how to distribute? That is called monitoring. In a similar manner, if less amount of water is available, how to be distributed among several people? So that is called monitoring. So the monitoring in a similar manner in GIS platform, how to monitor the data? The monitoring data is definitely be understood if you understand the limitation of assessment of data sets, whether the data sets are readily available or not. Then you see, once you are doing works or you are going for the research works in the region of climate, a climate problem you are interested to solve. So during climate, you know the normal climate parameters are like this. Suddenly the changes occurs. So for that, what factors are responsible for bringing the changes in those prolific areas that you have to analyze or that you have to enlist. Once enlisting those parameters, probably you can get an idea in changing climatic scenarios what plus minus I have to take. That is called data interpretation, or rather you can say data management by taking the help of error percentage evaluation. And then several parameters like population growth. Suppose you are considering a problem in urbanization area, so you have to, which parameters you have to consider? Definitely you have to look after the population growth. Similarly, if you are interested to understand the water quality, then you have to depend upon what should be the pollution index criteria, what is PIC. Once you understand the pollution index criteria, what should be the uh, contamination percentage, that also you have to evaluate. So some examples rather I am telling what are the challenges broadly in water resources engineering to assess or to understand, okay, or to solve rather. Then in GIS platform, how the real-time data collection is possible. So this is being categorized like this. One is either through online activity or through server or through app activity or through sensors, that is Internet of Things, okay, IoT rather. And another one is probably this word you may not understand, which I want to tell you, that is called click stream. Who can say what is click stream? Anybody any idea? Because several researchers are sitting here. What do you mean by click stream? A word I am putting you. All other things probably you understand, which I don't want to discuss, because my idea is what is the architecture of real-time data. Architecture means where from you will get in a single platform. That is called architecture of realistic data or real data. So as I am telling you, that is called click stream. The very simple is the simple assessment. Suppose say you think about click stream means a file. Click stream is nothing but it is a file, or you can say a folder, where all sorts of data you are stripping at a single place, and you are, suppose I was having a project in Department of Science and Technology. The part was only to accumulate data at a single platform. Some research scholars were doing that one. He accumulated all the data, keeping in that device or in a folder, and the ministry is borrowing from that folder to interpret. Are you getting? So that platform is nothing but, that is I am telling you, the that is called click stream. Okay, or sometimes that word also you can put check stream. There are several stream patterns will come, which you gradually understand. Then you come to understand what is CDC. CDC trimming tool. As I am telling you, all the data are accumulated in a single platform. Then what you have to process, in what way you have to process. That processing tool is called CDC trimming tool. CDC, you extract all the data, keeping in a single platform, then you extract through a via or through a barrier, through a carrier, and that carrier is called a stream processing tool. So once you get all the data, so that stream processing tool, then you have to go, you have to divide the entire class into two platforms. One is a real-time query, another one is a store for later uses. Because today I am having a problem. For this problem, I am a water resources manager. So I am having several data with me. I am keeping this data in this folder, I am keeping this data in this folder. So at present, looking to my problem, which data I should extract it, and that at present study or at present query is called real-time query. Are you clear? So, and for that, for the future purposes, if something, suppose this is a town, the people number is 500, day after or after 20 years, the people may be 5,000. So looking that is called storing for later use or for future use. Okay. So for that purpose, I have to quantify. Once I am a researcher, I am carrying out work, because you are writing a paper where you are extrapolating that this is my work, and the future scope is this. In a similar platform, in a GIS platform, you have to also extrapolate like this. So this way you have to understand. Then it's carrimination. Carrimination is the research work after analysis. One is a, that is you can do it in the real class platform, that is called real time applications. Another one is a, you can apply it in the field of, as I was just in the afternoon session, I will come for that, which is my heaviest area or my strong area rather I can say. In the afternoon session I am keeping it in different tools like artificial intelligence, machine learning or something like that. Because you see, this is a preliminary tool for any researcher. You start from GIS, come to MCDA, then you come to your artificial intelligence. All three are conglomerate. It means integrated. Then only a researcher will feel, hey, I am too healthy. You are too weaker to me. Are you clear? In that sense, rather, so that's a very stepwise manner. I am coming here not to show you the slide. I am coming here in a real perspective, the people who are, I am coming here to get an opportunity to grasp you, to have a communication with you. Are you clear? Because we think probably I am not the big pandit or I know everything such that. You are the people, you are sitting at the other side, you are also much more knowledgeable, even if everybody has same knowledge, what I understand from mine. But how much you can exercise, that is much more important. So once you exercise, all the water researchers, family members, as you are sitting with me, I want to give you a single message that whenever you are getting a problem, first be realistic. Be realistic. For this problem, what should be the time, what should be the data, what, because you do not understand how do you write a project. If you do not understand what should be the parameters for developing a problem, if you do not understand what should be the length of completing the project. So that's why I am telling, for a researcher, the real-time data collection, real-time data analysis, real-time data application, all three should be in a single platform for realistic association or realistic development. So that's why GIS is no longer, or any technique is no longer out of the scope. Everything is in a systematic way. So that we have to look after first being a starter or being a researcher, a beginner researcher rather I can say, or any peoples like we mediocre or something a very energetic one. So in any way, this is the process, general process. So what are the benefits we will get when we will use the remote sensing in monitoring water, particularly in water field rather, how to monitor water, what should be the benefits a water resources engineer or a water resources planner or a designer can get out of it. You know, the spatial resolution is much more important for that purpose. How you resolve the space, how you resolve resolution means putting in scale. So how you put in scale, either whether it is a small scale or it is a large scale, that is much more important. And in particularly, the resolution can only be possible and will be more healthy if you look after the space component. Then what are the challenges of remote sensing in water monitoring? First, you know, suppose you are taking some data, you are doing some, you are ready to solve certain problem. You are going to, suppose day before yesterday, a simple example I am taking, a burst of a pipeline occurs. Water is being coming, it cannot be automatically being stopped. So somebody has to work upon it. Am I right or wrong? So if somebody has to work upon it, unfortunately or fortunately, if fortunate enough, work is being simulated in time with respect to realistic approach, then people will not create any problem. If by chance rainfall occurs, some resistance is coming into picture for not to compute the work, then there will be a question of creating havoc. Automatically there will be a very bad phenomenon which may occur. So some also, whenever you are going collecting data, some parameters which are resisting, which will challenge to apply the remote sensing, those are, what are those? That is I am going to tell you. One is if you cloud cover and weather interferences. I was telling it is a foggy day, so the aeroplane is not supposed to start. So that is what? That is by nature. That is by the interference of weather. And similarly, whenever you are interpreting the data by certain method, and you are not taking care of the data set normalization or data set scaling rather I can say. What is normalization? You have to put in a single scale, or you have to put into a according scale such that you can work for that by the standardization of the method. If you if you do not understand, it is called the data interpretation and validation, or that is called data interpretation. Once you interpret, you have developed something, then you validate by proper method. If it is not possible, then your method is wrong and your assumption is wrong and your quantification is wrong, such that you are giving a wrong message or a wrong quantity approximation to the society. So for that purpose, the challenges are too many. So that challenges probably you have to look at. And second one is, suppose I am a very poor man, okay, I want to go for 5 rupees per day, I am getting 5 rupees per day. But if I think about I will expend for 10 rupees, how it can be possible? I am going beyond the my thinking. So in the same sense, if you approach the costs and the technique expertization, suppose I am a man of water resource engineering. I fortunately know the structural part something different, but it is not necessary that everybody people know. I am a man of water resource engineering. I will go for the design of the bridges. How it looks, or am I right or not? Or probably my lack of knowledge in a similar manner, whenever you will go for the spatial data or yes, there are two types of data you will broadly get. By frankly speaking, you will get spatial data in several platforms. Second one is temporal data in several platforms. So what is the difference between spatial data and temporal data? The data which is escalated in terms of space or in terms of position, rather I am telling you, with coordinate system, that is called spatial data. बट व्हेन यू लुक आफ्टर दैट, बट फॉर दैट स्पेशल डाटा, भाई हम आपको एक काम दे दिया और आप 2 साल 4 साल 6 साल एक प्रोजेक्ट आपको मिला 3 साल के लिए, आप 30 साल लगाओगे. इफ यू गो फॉर 30 years, कैन इट बी पॉसिबल? सो यू फेल. सो फॉर दैट पर्पज, whenever you will special, I need one paper by 1 month, but what you people will do? है बोला तो बोला, अरे चलने दो ना, गाड़ी तो चल रहा है. हाँ. So if you concentrate my ideas, I may be energetic, I may be thrusting, you might actually the spatial data extrapolation from different sources. At the same time, keep in mind the time. So if you interpret, conglomerate, or intermingle both space and time, and then the data will be spatial temporal data. And with the, देखो मेरे पास 5 rupees है, I am not happy. 5 crores है तो yes, I am energetic. In a similar manner, if space and time both are integrated, then your data is healthy. So monitoring data is only possible when data set is healthy. Are you getting? So this is a message. Okay, your friend, rather Vibhu is already alarming me for a break. So let us make a break. Tea break rather. Chalo. And this is slide number only. How much it is? 36. I have to come to 122 bhai. 122 for this session. Okay. Okay, in anyway, I am getting an interest because wise, now 45, 46, 50 papers people are going on. So we are already working, we have no objection. And another 14, 15 years my job is there. Or we people are at that. But your career looking to the entire mass, I found everybody is at the level of young entrepreneur or young researcher. Okay. So I think maximum. ଆମର ସିଟ୍ରେ ଯେଉଁ ITR ଯେଉଁ ମ୍ୟାଡ଼ାମ୍ ନାଇଁ ଆମ ସାଙ୍ଗରେ ଯେଉଁ କାମ କରୁଥିଲେ ତାଙ୍କ ନାଁ ମୋ ସାଙ୍ଗରେ ମୋ ଥିଲାବେଳେ ଯେଉଁ ସେମାନେ କାହିଁ ଦେଖୁନି ସେମାନେ ସିଟ୍ ଛାଡ଼ି ପଳେଇଲେନି ଦେ ମାଇଟ୍ ବି ଫ୍ରମ୍ ଷ୍ଟ୍ରକ୍ଚର୍ ନା ବେନିଜିର ହଁ ବେନିଜିର ହଁ ଜିଓଟେକ୍ ଆଉ ଜଣେ ଗୋଟେ କିଏ ସେ କୋଉଠି PhD କରୁଛି because all are water resources na very good. This is very matlab such a even if at our NIT or even if IITs, I have gone to some other places where we cannot get such a good platform where people are associated like this. It's very good because of Bhubaneswar, I think this is a good integration. Several private colleges are there. I was also working in private college not less than 12 years or 11 years. Okay, and I enjoy that. To be very honest, whatever the I have learned by there is no guru, there is no I myself. Okay, I have driven on a seat where there was I was on a car where there was no driver. Okay, but that is only by mercy of God. I have probably God has helped me to drive my an unseen car. Okay, so in that sense, I am telling you, if you are quite energetic, if you are working in a proper field, nobody can take your path. Okay, because I am seeing so many energetic people, youngsters are sitting. Their career is definitely at the very bigger end, and water resources. Because man of water resources, I may know structure, I may know other things, but water resources means there is a question of integrity. Okay, so from that sense, I can say you three things. Particularly, I am a man of hydrology. I know hydraulics, I like hydraulics, but by compensation or by certain resistance, I cannot work in hydraulics because I was quite interested for doing works in hydraulics because of some problem. The people who give me resistance to work in the field of hydraulics, they are now suffering. They are now thinking, probably we have done the mistake. Okay. So my main theme is, if you are really a worker, what is hydrology? Probably 10 years before or 12 years before, I was not known at all. Now, to be very honest, I have not done a very huge work, a mediocre type of work, but still then I am happy because I have done something for the society of hydrology. Okay, so in that sense, I am telling you, people are too many. People are too many. If you ask me a question, why I am telling such things, if you put me a question, then hydrology is such an area where you can not only work, you can not only learn, you can earn also too many, you can also share several things to the society. Okay, by means of writing papers or by earning something or something like that. But as a whole, hydrology is 99%, I am telling you, more associative for the entire water resource. Okay, let me come to the point where I was. Now, I had discussed regarding the real-time data collection and now what should be the benefits of using remote sensing in water monitoring. Probably this also I had discussed. Then challenges of remote sensing. I am going backward or forward? Forward. Then what should be the future trends and opportunities? As you know, the advancements future trends, obviously, if I am having certain knowledge, what I should think. If I am a real worker or researcher, I should think I should learn much more. In a similar manner, if you understand the advancements, what are the advancements are really necessary to understand remote sensing technology, and you should have a interest towards that, then advancement in remote sensing and technology is possible. But what are those advancements? As I was telling, to learn those advancements, you have to know the integration. So what kind of integration? You are coming with remote sensing and GIS. Integration means once you analysis what remote sensing and GIS does. By remote sensing and GIS, you are only gathering the data, and into some extent you are creating an environment for I can say for keeping all types of elements in a good platform. But beyond that, you are not doing anything in remote sensing and GIS. So for that, what is necessity? Integration is required. So how can you integrate? Integrate through several other technologies. That is called advancement or advances. Okay. How it can be possible? If you integrate with artificial intelligence and machine learning, or if you integrate with MCDA. Okay. What is MCDA? That I will come. Gradually I will come. So, or if you collaborate with big data analytics. What is big data analysis? Which I will tell you in machine learning. Okay. And in a similar manner, after integration, if you can give a potential thinking for policy making means if its application part will come into real life picture. I mean, for the state government or central government authority, those who will implement whatever you have developed. So for that development, suppose you are developing a project, you are developing a patent, you are developing some paper. What are the outcomes? That outcome based things will come into a single platform, maybe to the agencies like state government or central government. By looking to that your findings, they will utilize in realistic field. So for that purpose, the policy making and the management in sustainable environment, or in the management in the environment which demands. For that purpose, we have to work together. So what is the, now I am coming to my area, I am jumping straight away. Whatever I was telling really in realistic field, I was entirely discussing, thrusting my ideas or my knowledge, sharing only to the whole platform water researchers. Now I am concentrating, I am gradually coming from whole to part. I am coming to my hydrology. So in hydrology, as I am telling you, we have to concentrate upon the analysis. Analysis may be made through spectral analysis. Analysis may be through thermal imaging. Analysis may be through radar and lidar. Analysis may be through microwave remote sensing. And in different areas, if you look after spectral analysis, then spectral analysis is more suitable for detection of water quality. Okay, or water detection in one sentence I can say. If you look to thermal imaging, then you definitely think about the parametric changes at a level of climate issues like temperature, like humidity, etc. and etc. So for that, thermal imaging for temperature assessment, only temperature, because thermal imaging is only meant for temperature assessment. Then if you come to radar and lidar, then radar and lidar, it is, through radar and lidar, you can only get the mapping. So mapping to understand how much water is readily available. So what you have to do? You have to go for the area location. You have to go for the surface water management maps, how much water is available. If you can extrapolate the entire area from mapping, then you can say. So in a similar manner, you can extrapolate the remote sensing techniques, particularly microwave. What is microwave remote sensing? Microwave remoting to understand or to acquire some knowledge, the soil properties. Okay, soil moisture content, like what is liquid limit, what is plastic limit, what is shrinkage limit, all these things can be possible. So in that way also the, again you can put me a question then how hydrology is being associated, because hydrology, I mean soil and water are interactive. So that's why. Then what are the benefits for using remote sensing in hydrology? You see the benefits you will get. One is the large scale coverage and spatial resolution, cross spatial resolution. You can go for the large scale area or all the activities, whatever you can do. Then the real time data collection, whatever the data is readily available. Then the effectiveness, the continuous monitoring capability, and facilitating the decision making process. All these parameters you can extrapolate and you can think about it. Then what are the detection? In general, in hydrology, what are the detections are doing and which detection part I have done my own things also I will tell you. In general, the detection of change in water levels with modern techniques and modeling. You see, my first paper was published in Journal of Hydrology. You might be knowing what is Journal of Hydrology. Whenever I was at the level of MTech to PhD integration. Okay. So my first paper, and I think till today that is my best paper. Okay. Of course, ASC paper has already come, already published. One or two has already published. No, sorry, one has already published. Two are under revision or something like that. Whatever I have done, but still then I am giving 100% guarantee to my Journal of Hydrology. That paper I will also show you. You can understand at that 10 years how I was working. Okay. Now, so the thing is that without any driver, as I am telling. Okay. So in any way, the geophysical investigation techniques are quite associated for detecting the changes in water levels. So geophysical investigation techniques are what you know, but I am just discussing. One is the resistivity, electrical resistivity survey. Another one is the seismic survey. Another one is the electrical resistivity survey, seismic gravity interaction. And another one is interaction with magnetic methods. Why I am telling? Because I have done a lot of consultant work in this area. So that's why I am telling. Particularly to sense the groundwater, these methods are much more important. Okay. So you know electrical resistivity method, it is a very common method. Any geologist, they are usually use this method for searching where the groundwater availability is there. Then these occupy all preliminary things I am not going to tell you. Then another one is satellite based groundwater monitoring. As you know, there is a great potential for satellite gravity observations, specifically when in situ measurements are inadequate. When in situ measurements are inadequate or inaccessible, not possible, during that time we can take the help of satellite based groundwater monitoring. Then the regional groundwater estimation through numerical modeling. Now these parts are coming. I have never worked in numerical modeling. I am always working in GIS and my best area is, as I am telling, artificial intelligence, machine learning, etc. But I am telling you this part is also important because the numerical modeling, once you are a good engineer, numerical means whatever the physical sense of approach, you have to convert into numerics. Such that through numerics, your learning will be much more easier. Through numerics, you can assess properly the database thing. Anything, if you are writing in several formats, say an example, a person having 5 centimeter or say 5 feet high, normally 6 foot or something like that. But if a scale based orientation is there, then to understand numerically by certain programming or something like that, it will be much more easier. Because one steps I am telling you as an example, choose a tool for step 1. Okay. How this regional groundwater estimation is possible by numerical modeling, there are 6 steps I want to say you. First you choose a tool, then you put what are the parametric equation ready or necessary. Then step 3, you have to develop the model, step up the model. Which model you have to utilize? What is model? Modeling means nothing but you have to develop an equation. Okay, y is equal to mx plus c. Y is the dependent or independent parameters? Dependent parameters. So which one is independent parameters, at what level you are going to consider? If you develop that equation, that is called step up model or step up equation. Are you clear on it? Then what you have to do is you have to come for the selecting the, the boundary conditions. For developing that equation, what should be the boundary conditions? Boundary condition you better understand, x, c, y, whatever the parameters you have to assimilate. Then you come for the initial conditions. Then you because for setting the boundary conditions, your initial conditions might also be depending. And for that, you have to go for, once you are developing all the parameters, once you are developing the equation, and once you are developing the parametric equations, then in that tool, you go for running. Run it. You are developing the model, you are developing the program, then you run it, you will get some inputs are given, equation is developing. From equation you are putting the equation inputs, then you will automatically get some outputs. So that's why this is a generally this is a numerical model and which is much more accurate, even if any methods you can sustain. Okay. But beyond that artificial neural network or that machine learning, that I will tell you how it is different from this numerical modeling or something like that, but during that time. So then use of satellite imagery to monitor water bodies, rivers, lakes and reservoirs. Because you know, so for a satellite imagery, for water bodies, definitely the color should be different or the waves should be different or something like that. So for different imageries, different satellite imageries are being used to monitor the different types of features. It may be if it is water body, what should be the feature, if it is a river, what should be the feature. Water body, I mean, I am telling you just like our NIT Silchar campus, several water bodies are there, small. Are you clear? Don't say. So similarly, if you come for rivers, if you come for lakes, and if you come for reservoirs, and even if for roads, buildings, etc., which I have not put it, but being a water resource, I am telling you if these are the elements, then what should be the imagery, and that is you straight away you are getting. So then what are the applications, particularly using remote sensing? One is surface water monitoring, second one is satellite photography, third one is monitoring snow cover and glacier movements, because some video I have shown you already how the glaciers are being melt under certain temperature conditions. And yesterday the glacier magnitude was like this, and today it changes. So this is only possible if you take day-to-day satellite images. So that's why the monitoring you can get it through snow cover changes. Similarly, if you look at to the remote sensing aids in then snow cover glacier mass changes that you observe, estimate of soil moisture or any problems or any parameters, whatever you like, that is possible if you take the satellite images. Then surface water monitoring, these are examples few. Then groundwater exploration and management is also possible by remote sensing techniques like thermal infrared photography, radar, and which can look at prospective groundwater resources. And that the similar approach is similar. You have to observe the water levels, because you groundwater data you can get from state government agencies, that is called what it is. You either groundwater data is finding from at Odisha level, that is called what? Groundwater board. So from Odisha State Groundwater Board or something like that, OSGB or something like that. Anyway, I have forgotten. So in any way, you have to get the water level changes. Today, water level is generally recorded for today, for tomorrow, or season-wise generally it is recorded, probably during monsoon period. Every 3 months the water levels are being recorded. Once it is being recorded, then your work is how the changes is being observing. That is, you straight away by putting monitor. So monitors are working for what? The sensor. So sensors are from sensors you will get the images. So is it not the GIS? Is it not the remote sensing? So that's why you have to look after. So that's why I am telling you. And you know, in a similar pattern, if you think about evaporation losses or evaporation rates, the same approach you can take. River basin management. So several applications in terms of remote sensing and GIS through imageries you are getting. All these things I don't want to. Then estimating precipitation using remote sensing data. In my laboratory, well, I have joined to NIT Silchar. I have procured an equipment where my first PhD scholar Sandeep was. He has also worked. Okay, he is now placed in NIT something. Okay, so in any way, he was worked with a equipment that is called rainfall simulator. Okay, whose cost is more than 35 lakhs or something like that. So what is that rainfall simulator? It sends the data. There is simply water logger is there. From that water logger, what will happen? Whatever the rainfall, artificial rainfall. Suppose say 5 millimeter per hour, 15 millimeter per hour, or 25 millimeter per hour, the rainfall occurs for certain time. Then it can be monitored by two ways, either through photography or through sensor. If sensor is there, then you can get the approach of remote sensing. Okay, so remote sensing means the sensing of the equipment, and in that connection, all the recorders are there. They will go for the recordings. They are actually automatic, artificially, that is built up in device. But here, what you have to do is, once precipitation occurs, you have to concentrate over some weather station. Weather station. Weather station you might have seen CTV weather station might be there or some institutes. Weather station means if you if you want to how much rainfall occurs today, okay, there is in weather system the entire integration is there, how much rainfall occurs and how much humidity today, how much temperature is today, all things. So the entire assembly is called weather station. So from that, whatever the data you are getting, then it will be transferred either through as I am telling you, some systems like that is called data logger. Then once precipitation, it means I want to give a message that it can be sensed by two, either through water station, weather station, or you can say through your that is called what? Satellite. That is TMM satellite. Are you clear on say? So you can put me a question in between these. What is the difference vertical? Because satellite data will definitely be more accurate, and because this is a recorder, whatever is the artificially we are giving by some mathematical data, it will record. But whatever naturally is being getting directly straight to broadcasting, that is you can get. So these two intermingling and a comparison if you do, you can understand what is the error, what is the model development, or what is model accuracy that you can get. Now that is that TRMM is a satellite, and that is definitely a data whatever you will get. What is the full form of TRMM actually? Tropical. Tropical means regional, or from the area you will get. So if you get from the area the realistic data, so is it better or a logger microwave? This is a microwave based system. So that's why I am telling you then whatever the data you are getting, after that what you have to do, you have to think about the accuracy, whether it is a satellite based data or from a weather based data. Then you have to give the spatial interpolation by taking both the data. You take spatial interpolation of that system and this system, I mean weather station system and TRM satellite system. Then you have to think about the comparison. Then you have to apply what should be the methods you have to adopt. So for that, generally conditions will be applied. So to understand that conditions, you have to improve multi-sensor, as your friend is asking. Sensor, you see, accuracy, if you are applying one sensor, accuracy, two sensor, multiple sensor, so you will, depending upon the setting. So sensor based data is more way it is utilized for accuracy point of view. So then all these things I have discussed, but I want to give you one message that evaporation, event tool management, and simplified surface energy balance method. All these are methods. Whatever in this square, all are associated methods. Okay. So in details, if you just take this slide, you can go for that. Sebal is a method, SEBS is a method, metric is a method, SEBI is a method, ATMA is a method, SSBOP is a method. So all are methods. Are you clear on say? So that's the full forms. I cannot tell you, or I am not interested to tell you whether all these are being developed methods by putting certain equations. Okay. So anywhere from net you can search and you can find out in details. If you want to go, you can go for that. But only one thing is I can say you what are different single source models and what are different two source models. If you are interested to develop a model single source, you can utilize these methods. If you are interested to utilize two source models, you can develop these. You can interact with these methods. These slides you can also take. Then they are important, my area, flood prediction. Okay, flood prediction is an important parameter. Flood is you can understand. Flood is what is flood exactly? Flood is better than that. If anything overtopping is known as flood. Any water overtopping at any system is known as flood. So flooding can be possible in surface. Flooding can be possible in river basins. Flooding can be possible in small water storage. Water storages, etc., or water storage reservoirs, etc. In any way, the flood mapping prediction through satellite observations is also much more interesting. Why? Why much more interesting? The simple answer is because you are sitting here from USGS, you are getting the data and you are extrapolating how much water is readily available. So that by through imagery, you are here and you are estimating the water ponds at USA. So is it not interesting? So that's why the imagery process is much more interesting and required also for future purposes as well as more researches. Flood mapping prediction through satellite observations. These things I am not interested to tell you. And through satellite observations, you see how to get this satellite observation. There are several features. You see, here is a river. Okay, sorry. You see, this one is a river system. Okay, and one imagery you are getting like this, where the land uses are there, where the river system is there. There are several grassland, there are several forest lands, etc., etc. 1, 2, 3, 4. All these 4 are imageries with different types. As I am telling, this is soil type, this is land use type, this is distance to river type, this is the rainfall pattern. So 1, 2, 3, 4, all are different or not? So when you integrate, all 4 are different, but at a single place. So when you 4 will integrate for a small process like this, then you can understand what will be the problems come at different fields, where is supposed to be the flood event point, where is supposed to be located, where you have to observe or where you have to positioning the flood points. So that is important. For that purpose, what should be the features and which features we should construct it for flood happening or experiencing the flood event, that is more important. And for that purpose, we will come to certain methods, which I will gradually come. This is 52 only, sorry. Then prediction through satellite observations. So these things I am just skipping because this then this is GIS in water resources management. Spatial analysis is just a repetition, I think. This is infrastructure management, not a repetition. This is a repetition because I was telling the different hydrology, these are different tools. From that, for any area, you can manage. After analysis, why I am keeping 2 photographs? Because after analysis of any certain area, you can go for the result and management system. Okay. So for that purpose, this slide is being shown to you. Similarly, watershed management in a similar approach. By understanding watershed management in GIS tools can help you to understand what should be the delineating watershed, what should be the land use parameters, what should be the areas where this much of irrigated lands, etc., etc. You can classify, rather you can say, and what should be the proximity for future prospects. Today it is irrigated land, tomorrow it is being developed for infrastructure or something like that. So that prospects or that scopes you can get from imageries by sitting here in other places, for other places. Similarly, what should be the decision support systems? Decision support systems, you can get it as an appreciation if it is GIS based, if it is integrated, and if it is GIS based for some decision making processes. I will gradually come you. Decision making processes are one of the best method, that is I will come gradually, that is called MCDA method. I will come gradually. And how the emergency response and planning to be made by integration of both GIS and MCDA, that we will discuss a little later. Then integration is just coming. Integrated GIS with MCDA. So now there is a part. GIS part is somehow might be some of you person might be better. I am in theoretical. Some of you person might be better in practical. Those who are working with tools and so. So those people, more specifically, I want to give a message. You try to integrate with some other methods, like you integrate GIS with MCDA, like you integrate GIS with machine learning, like you integrate GIS with some vulnerable logistic, different types of artificial intelligence methods. Gradually, I will come even in the afternoon session. Then you can realize, because all 3 will be little bit interesting to integrate for paper development, for research work, for development of patent, for development of project work, something like that. So that's why I am intermingling all these 3 things, particularly in the area of hydrology. So let me start with what is MCDA, what is GIS. Unfortunately, I have already told, but in any way, what is MCDA? That is a very interesting topic, because probably we do not understand. To understand MCDA, I will also show you one video such that it will be a little more interesting. So what is MCDA? It is similar to a cost benefit analysis but evaluates numerous criteria rather than just a cost. Suppose for example, I am going to a market. I have seen several types of bananas readily available. Several types of bananas, I mean bananas which are readily available for me in that 4 to 5 types you might be showing. So if I understand the criteria, suppose criteria will be what? Suppose this banana costs 12 rupees, this banana costs 5 rupees, this banana costs say 80 rupees. If I understand A, B, C, three categories of samples, and if I understand also the benefit, for benefit, what I have to think about? Money, directly money. So if money is less, I may get benefits. To understand in a similar manner, I want to give a message. If some parameters are ready, which parameters should be responsible for selecting a for selecting any item? That is most important. And by which, why we are utilizing these methods? If I utilize 5, 6 methods, out of 5, 6 methods, one method suits for a particular item, it will be helpful for economic, it will be helpful for our pocket money, it will be helpful for our possibility of procuring. Am I right or wrong? So for that connection, this MCDA part is most important. As I am telling in a day-to-day life prospects, in similarly, this MCDA method is available or readily useful for all sorts of fields. To my extent, I can say it is much more effective for all water researchers perspectives. Okay, how it is. So to understand that one, I should go for certain theories. MCDA or multiple criteria decision analysis is a structured process for evaluating the options with conflicting criteria and choosing the best solution. There are several criteria that will come into picture and we have to choose which one will be more economic, which will be more sensitive for the purposefulness, then we will strike back to that solution only. So what is the best solution? We have to choose. Means there are several solutions. For a problem, there are several solutions. We have to choose the best solution. So for that MCDA criteria is or MCDA method is best one. So at WS1, 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 WS2. You see what I am writing. The preferences is how important are the objectives. And the decision is good flood forecast and alert system. That is I am telling you is a WS1. There are several flood forecasting models I have developed. And I am telling for forecasting, for fast flood forecasting, suppose I have considered the input criteria as 12 only. Second flood forecasting, I am going for 21 criteria. For next one, 51, or even if, but out of 15, 25 or 51, whatever the parameters I am considering, which criteria give much more influences or effectiveness for creating flood, that should be chosen one. Depending upon those, even if I am selectively gone for 5, 6 methods, which one is the best one? For that purpose, this MCDA method is utilized. One example I am telling in the areas of flood situations or flood event creation and how to mitigate floods. So one problem I can say. Similarly, if I go for groundwater monitoring, how much water is readily available at what depth, what should be the parameters. Parameters you have to choose because you are the researcher. Parameters some other people cannot choose. But different parameters combination and bringing the identity for a model development is your knowledge. That's why you will be the researcher or you will be the designer or you will be the planner, whatever you can say. So that's purpose. Probably this is the video. Video is not coming. So you just listen 2 minutes, whether I am getting a handsome break. Okay, these are two examples as you are getting right now. In a similar manner, the main point is what is the importance of integrating GIS and MCDA for decision making? What benefits we will get out of it? The benefits number one, we will think about the improved decision making. The improved decision making can only be possible if we think about the spatial analysis with decision criteria. Suppose some area we are going, if we analyze the spatial, matlab GIS, and if you integrate with the decision criteria, then we will get the improved decision. Okay. Similarly, if we think about the complex problem, what are the complex problems readily available? So several combinations, several criteria are there to integrate with the GIS platform. If we are getting, then there is a question of not the problem looking linear. Matlab linear approach or linear decision taking is impossible. In that connection, we should drive to the complex problem solving. The next one is when we think that visually the problem is quite complex, we think that the relationships or correlations between all the parameters is quite complex. And when we think that geospatial, matlab with respect to GIS, the problem is also complex, then it is possible for integrating. Once we integrate, then the problem will be much more easily solvable. That is the message I want to give you. Then the question is, if we allocate another one parameter, that is called optimization, maximum or minimum. If we think, then we can sort out a great problem within our proximity. So that will probably be much more helpful for taking a decision. That is called decision supportive rather with the help of data integration with MCD. Yes, 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 yes. definitely how it is, that is I am extrapolating. Suppose by MCDA what we are doing, we are giving some weightages or we are giving some ranks. We are putting all the parameters as you are telling. If the flood is low, we are giving one single parameter looking to your situation. If you think that the flood is low, you give a weight suppose 5. Medium, you give a weight suppose 10. High, if you give a medium is suppose 15. Your question is how we can integrate. The integration is possible if you go for several criteria like low, medium and high. Because your parameters output is flood. You are, what you are doing exactly, you are choosing. After, if this rainfall occurs, this runoff is coming. After this rainfall runoff, this is the low flood, this is the medium flood, this is the high flood. So to distinguish or to put ordinary criteria, you are giving some scaling or ranking or giving some weights. From that you can easily distinguish which one will be much more or which one will be the low flood, which one is the area of medium flood, and you can extrapolate. Where high flood is supposed to be occurring, you give the sense to the state government authority such that they will take the necessary actions to minimize the flood. Are you getting? So in that connection, this method is very interesting because of less time, because of less integrity. Okay, because whatever the complexities you are getting, only what you are telling, you are selecting the parameters and you are classifying the parameters by putting certain words. Okay, in this way it will be much more helpful particularly. So what are the different MCDA techniques? Now I will tell you, because this MCDA techniques is definitely a carrier burn project or carrier burn model which should be taken by some weighted. So by putting certain weights, okay, which already by, for example, I have already discussed, and then different types. As I was telling, one is called AHP, analytical hierarchy process. So your goal is what? What should be your criteria? 1, 2, 3, 4. What should be your alternative criteria by integration? Okay. Goal, criteria, then the alternative criteria you can also put. After that, if you assimilate, you are getting the weights is this one. And there are two ways, there are two approaches. You can put certain weights. These weights is vulnerability for achieving this goal or applicable for achieving this goal. That weight you put it, but that you have to do. Researchers has to do. Are you getting? But depending upon a scientific thought or depending upon a logical thought, whether you can integrate in that way. Then comes order of preference. For this ideal solution, there are several other methods like TOPSIS. TOPSIS is the best alternative by measuring shortest distance from the ideal solution and the farthest distance from the negative ideal solution. So the category is like this. And you how to utilize TOPSIS, that you have to again think. TOPSIS ka full form is technique for order preference by similarity to ideal solution. Okay. So this is generally, and what is the procedure? This is already you set criteria, alternatives, decision matrix, positive ideal solution, negative left, right, etc. Then you put the rank and you find out the solution, which one is the best rank offering. You go for the solution by this TOPSIS method. Similarly, another one method. All these are likely same. Approach is likely same. Only you have to, how you are putting the weights, how you are putting the ranks. That depends. Logically, all are by different names, but item is same. So in a similar manner, you come to elector, that is elimination at quakes. It is by the name of the scientist and Traducent La Riley. He is a foreign name, a scientist, and he has given this all the characteristics as this is a logical characteristics in comparison to other two ones. Then similarly, Prometheus, this is a preference ranking organization method. So what the knowledge you are getting out of it, you only understand the methods, what are readily methods available and how to hit all these methods. But the approach or analysis is nearly same. If you integrate or if you think something different, it will be more energetic and more enthusiastic for solving the problems. Otherwise, nearly same. Similarly, what is SAW? SAW means simple additive weightings. So for that, a program is there like this. start, read the criteria, score, read provide and score, compute the criteria weight, then you go for the normalization. Sometimes normalization is necessary. You can put me a question, why normalization? Because a complex criteria. Whenever it may be artificial intelligence, it may be MCDA. Normalization is a criteria only because you see why normalization I am telling you. Suppose today the rainfall occurs today is 50 millimeter. Tomorrow I do not know, it is a heavy rainfall to 50 millimeter. Okay. The model which you are going to prepare probably for this year. Next model whenever you are going for probably another 50 years. So whenever you will come and it will be a mean or arithmetical sum, then definitely the model will be better for prediction or for future prediction, rather whatever you can say. So that's why we are going for the additive weighting and we are going for the normalization matrix, whatever the methods it may be. Then you compute the final score, rank, and finally which one is best, which one is lowest, and then you finish your program or finish your identity or finish your work. Then you can understand which one is best, which one is worst. Similarly, MAUT, multi-attribute utility theory. This is more specifically utilized to assess the decision maker preferences and attitudes towards risk. This is a risk analysis criteria. Risk, whenever risk comes, true, false. Whenever under this condition, I will be the Prime Minister. There is a risk. I have to first resign from my position. Then I will go to the political people. beg, give some money, sir मेरे को एक एमपी का वोट दे दो, एमपी का एक पोजीशनिंग दे दो, मैं इलेक्शन लड़ूंगा. So risk criteria whenever comes, some examples I am telling, when you think about MAUT. Okay. So whatever that, particularly because it is not possible to within 6 hours everything sensitively telling, you just a mapping or the scale, whatever is the overall ideas, and this is as I was telling, some sustainability. It may be in terms of money, it may be in terms of social, it may be in terms of status, it may be some terms of prestige or something like that. So all the criteria make it, and then whenever it is a risk approach, risk approach means thinking the status. Then you try to utilize multi-attribute utility theory as per my knowledge is concerned. And similarly, Vickers, this is optimization criteria. It is compromise ranking method that identifies compromise solution by considering the best and worst outcomes for there is a method that is called best worst method. Okay. So best worst method is also a method, the other name is this one, Vickers method. Are you clear? In that way you can go, because some of my PhD scholar is also working this best worst method, Harshavardhan. So he is working in this, so I know into some extent, and that's why I am ventilating it. Okay. Then there is this is a very huge thinking, fuzzy decision making methods. Fuzzy decision criteria is quite energetic and enthusiastic, because this is only possible when you have to think about a membership function. Suppose you see there are 522 MPs are there, okay, and I am telling you, who told you why not the Modi can be gone tomorrow? Who knows? I will be in the jail if I tell like this. But in any way, so there is a possibility or probability. So my question is, if you want to, fuzzy decision means energetic decision and simplified decision, critical decision, whatever way you can interpret, but this is only possible when membership functions are taken into account. You can put me a question, sir, what is membership function? It is totally mathematics. There are several membership functions are there. And probably for that, again, another one story or another one chapter you have to read. So it is my sincere suggestion, you try to have a knowledge by your own. Through several videos readily available, you try to understand what are different types of membership functions. What you want, once you understand, because that is beyond my time does not permit me. So every alternate membership functions are required to understand the fuzzy decision making. One example I can put. Suppose membership function means it is a mathematical function. Mathematical function means suppose y is equal to f of x is equal to e to the power x plus e to the power minus x by 2. Any sigmoid function, straightway I want to tell you. Do you know what is a sine function, what is a cos function, what is a sigmoid function? Where sigmoid function is utilized, where sine function is utilized, where cos function is utilized. That trigonometric knowledge is much more required to understand for this fuzzy membership criteria. So fuzzy membership criteria always demands what should be the output, whether the output is 0 or the output is 1. If you think that if this criteria happens, I put set right, there are several criteria, 1, 2, 3, 4, 5 up to 10. 10 criteria is coming, 10 statements are coming. Out of 10 statements, you are putting, for this criteria, the value is 0. For this criteria, the value is 1. Similarly, for 10, you are in order you are going on. So for that, looking to the critical situation, you have to put the mathematical function also. Because when x varies, y also varies. So y is equal to e to the power x plus e to the power minus x by 2. Whenever I am telling, we are putting x, the y is varying. X equal to 1, y will be different. X equal to 2, y will be different. In similar category, I want to give a message. This fuzzy decision making, particularly in MCDA, is much more interesting when you thinking about the membership function. And membership functions, I am telling you, it depends upon by the lucrative problem. How much complex the problem is. If the problem is too many complex, you are not able to solve by ordinary MCDA methods, then you have to jump over to this method. That is the basic criteria for fuzzy decision making method. Whatever the logics that is I am not telling, you just read it through this. Then integration of special data in MCDA, how to integrate, the best method is this one, or the best steps are this one. First one is you have to identify the relevant special data. What special data is necessary for your problem. Second one is you define the decision criteria. What decision criteria you have to consider. Suppose as I was giving an example of if the banana cost is 5, 10, 15, 20. So for identifying the data, what should be the decision criteria, what should be the geo-referencing and data preparation. Geo-referencing matlab GIS is coming. So you see, first one is I am telling the special data, GIS. Second one is I am telling the decision criteria, MCDA. Third one is I am telling the geo-referencing data preparation. Matlab I am again coming to GIS. Then criteria mapping and weight assignment. Again I am coming to MCDA. Then spatial analysis and integration. Matlab here both combination here starts. Then you come to MCDA model development. Then you go for the analysis and decision support, which depends upon purely upon your research or upon your work, whatever you can understand. Then you come to the visualization and communications. Once you think that yes, my model is ready and my model is purposefully the best one, then you think whether these people probably regarding my problem they are accepting or not. If they are accepting, many people are accepting, then my model might be better. Then you thrust to the state government authorities or central government authorities or any authorities as you like, at the level of university, at the level of college, whatever you like. So then you give it for communication, then they will interpret it, they will utilize it in the realistic field or practical application. So that is the much more. Yes, yes. I have already told you, model is what? Model who is developing? We people are developing. So how we are developing? By some scientific or integrating methods. So for these integrating methods, the methods are like this. It is totally a sustainable based method which the researcher or any worker has to develop. And these are, suppose you see, to come to a college, it is my sense of attitude that I should come with full pant and shirt. Am I right or not? So that is a common sense. Before that, I cannot drive or I cannot come. Similarly, to develop a model, I have to put what the criteria that is a researcher has to think. And upon these criteria, because for plot, suppose I am telling you for plot, what should be the criteria? You know, what should be the physical parameters which will affect plot? What should be the weather parameters which will affect plot? What should be the climatic parameters which will affect plot? Probably you think that may agar physical parameters or IMD parameters, if I consider in temperature, probably temperature may not contribute to plot. Suppose I am considering, but temperature may sometimes contribute to plot. Suppose evapotranspiration I am considering, it may or may not. Suppose I am considering say humidity, it may or may not. So that approach is yours totally, researcher's approach. And depending on, because that's why your paper is accepted or not accepted. Because few people are sitting there, they are also evaluating. transporting through evaluation. What new things, that is called novelty. What new things you are projecting. Several papers in MCD are being thrusting every day. But what new things you are going to give it, that is called research, that is called your identity, or that is called your something new what you are bringing to the market. As a result, you will be sellable, you will be approachable, or you will be discarded, and paper will be rejected. Are you getting me or not? So in that way we have to work. Then what is a special decision support system? It is, as I am telling, it is interactive computer-based system designed to assist decision making while solving a semi-structural spatial problem. And it is designed because if you add GIS plus DSS, you will get SDSS, special decision support system.